All right, in this video, let's continue find all unknown measures on special right triangle. So we notice that we are using 1, 2 root 3 ratio on special right triangle. Another one, 1, 1 root 2 on the special right triangle. So it depends on the shape, okay? So let's look at fourth one on number 4. What is the name of this special right triangle? 30, 60, 90 degree special right triangle. So what is the ratio? So let's write down the ratio. Let me choose the pen again. This is 30 degrees. So opposite side from this 30 degree is 1, shortest length. And hypotenuse is longest. And the third one is root 3 ratio. Okay, 1 to root 3. And now we will compare it. So K goes with 1, right? And 2 goes with 8. Which one was first? I wrote K first, right? Given problem. So I need to write given number first and then my ratio in the denominator. If we write backwards, numerator, denominator, you do the same way, okay? That is ratio. On the left-hand side, you have ratio. On the right-hand side, we have ratio. Two ratios are same, and we have an equation that's called proportion, okay? Proportionality. So proportionality is an equation. Now we can solve it, and obviously K must be 4, right? 2 times 4 makes 8. 1 times 4 makes 8. So you can think about any kind of a right triangle with this degree, 30, 60, 90, small or big, or similar right triangles just like this has same ratio on it. That's why we have proportion, okay? Proportionality from similar shapes. Knowing that this will be also same ratio, right? 30 degree, this side will be 1, longest 2, twice of this measure, and the third one will be root 3, right? Root 3. So let's set up an equation to solve it. So what would you like to put on the top? You do the same way, okay? So I'm looking for n, and I'm going to use these numbers, okay? Two numbers are given, so let's set up an equation. N over 1, how about that? So I'm writing from the question, n over 1, okay? And then I'm going to equate it with number 6 over ratio root 3. And then you have equation to solve, cross multiply, root 3 times n, that's going to be 6. So you will divide this time, right? And then you can have answer. So your n will be 6 root 3 over 3, which can be reduced to root 3. 2 root 3, that is your n. By knowing this is n, can I just double m? M will be twice of that, right? That's twice. So I can have 4 root 3. How about that? And the third one is root 3 times longer than that. So you multiply by root 3, that will be just number 6. So we can check the ratio. Or similar right triangles here, right? So we have the same proportion on it. Next question below, I have differentiate 45 degrees, special right triangle with 90 degree here. So ratios are 1, 1, root 2 times longer here, right? So what would be measure for B? Same as this, right? So I will go with the same number on it. That's right. What is the length for the A? Diagonal over half of the square here, or hypotenuse of this special right triangle is root 2 times longer than one side, right? Root 2 times longer than the one side. So let's simplify. Root 2 times root 2 is just number 2. 2 times 2 is 4. So we can find all the answers by using ratio. Next one, this is number 4. What would be x and what would be y? Not sure, and then let's figure it out one first. And if I figure out x, that will be same answer for y, because this is isosceles right triangle, right? Okay, so let's find what is x. So what is the number on the length? 1, 1, root to 2 ratio, right? So I'm going to equate these ratios together, okay? 1 and x and 1 goes together, and I put the given information first, so I'm going to write number 4 first on the numerator, and root 2 goes together, so root 2 in the denominator. It's confusing, always write the ratio, okay, and then equate it, and we can solve it by doing cross multiplication. So root 2 times x is going to be product 4. So x will be the quantity 4 divided by root 2. Okay? Because it's shorter than this side. How much shorter? Root 2 times longer here, right? So I need to do division on it. Okay? So 4 divided by root 2. Can we simplify? Yep, that will be 4 root 2 over 2. So can we reduce it? So that will be 2 root 2. If x is 2 root 2, what is y? Same as it is, right? So we have x and y both 2 root 2. So diagonal is root 2 times longer than each side is root 2 times. We need to divide it. Okay, divide by root 2. Next question, what is the name of this special right triangle? 30, 60, 90 degree special right triangle. So what is the measure for the shortest one? Which is the shortest segment? Opposite from smallest angle, 30 degree, right? This is the pointy one. So this is 1, and which is twice. Hypotenuse is twice all the time, and this will be root 3 times longer. By knowing that, can you just take half of it to find what's y? Not half of it, I'm sorry. 2 times what makes 16? 2 times 8 makes 16, right? So it is 8 times bigger shape, right, from the special one. So let's think about doing the same way. So what is the number for 1 here? 16 and 2, let me write it. 16 and 2 goes together. Y and number 1 goes together. What is y? 8, correct, right? Half of it, 8. If y is 8, what would be x? Root 3 times longer than that side, right? So I can just put 8 root 3. 8 root 3. So if I know unit measure for x, I'm sorry, 1, and I can double it, I can multiply by root 3 quickly. All right, next one is a little confusing, so let's use ratio in an equation. So let's set it up equation and solve it. Which one is corresponding to 1? Shortest, right? Twice, which one? Twice. Longest one is twice. And the third one is root 3 times. Oh, I see relation. 1 goes to number 2, right? Okay, so you can set it up 2 and 1. U and number 2, right? So I put the question measure on the numerator, and I put the memorized ratio on the denominator. Cross multiply, what's U? 4, right? You need to double it. What would be V? V is root 3 times longer than this side. This side is number 2. So what do we do? 2 root 3. Okay, so we use the ratio instead of saying sine, cosine, tangent equations here, okay? So if we have a special right triangle, instead of setting up trig ratio to solve for unknown, if we can memorize the ratio and we can use it quickly.